Hello, good evening everyone. Welcome to Gradeup. I am Vikas Bhadoria and I welcome you all to this very important session on fluid mechanics. So as you all know that this startup series is going on the YouTube channel. In that we have covered few important lectures for the subject of fluid mechanics. Okay, and today I am back again with another lecture in this subject. Today I am going to start dimensionless analysis. Okay, so I will be waiting for you to join the session and then we are going to start it. Yes. So I hope you all know the timings of the lecture. It's every day at 9 p.m. from Monday to Friday. So I expect you all to join the session, and like I have told you yesterday that please share about this session to your friends, to your colleagues, so that they can also be a participant of this very important session which daily goes on the YouTube channel from Monday to Friday. Very good evening to you, Shivam Pal. Yes. Hi Harsha, Harry. Good evening to you too. So good evening all of you. Welcome to this very important class of fluid mechanics. Today we are going to study again a very important topic which is called dimensionless analysis, which is again a very important topic of the subject of fluid mechanics. Hi Naveen, very good evening to you too. So right now what I can see, we have few students watching us right now. Good evening Bhuvnesh Kumar, hi. Akash Manna, good evening to you. Naveen. Yes, I'm so sorry Naveen, I forgot that actually the class yesterday went up to I think 10:45, so after that I reached my home and then I forgot to check that question. Okay, so I will just mark somewhere that I have to check that question. I will just write it somewhere. Okay, so I will check it tomorrow. Yes Naveen, so tomorrow when I will be coming next for this session, I will definitely tell you that whether that solution is correct or not. Okay, so I just forgot, very sorry for that. Yesterday the class was very late, so I was not able to see that question. Hi Arun, good evening to you too, and welcome to Gradeup. Hi Abhishek Kushwaha, good evening. Raj Singh, very good evening to you too. So Raj Singh is in the app and all the other students are in the YouTube channel. So what I told you yesterday, yes. Yesterday I have told you that I don't like this number. It is a very small number. And so do you really want to compete with this only 10 or 15 students? I want you to share this to your friends, to your colleagues, so that more and more students should join us for the session. Okay. So you can tell your friends that this very important session is going on the session. On this YouTube channel of Gate Gradeup, so that they can also be a participant. Okay, definitely Naveen, I will definitely have a look at that question and I will inform you about whether the solution is correct or not. Or I will just write it in the comment box. Okay, so you can better see in the comment box. If there will be any error, so I will definitely reply in the comment box. Okay, Raj Singh, if you are waiting for the lecture, that is very good. Now, yesterday what I have told you the concept of boundary layer. Okay, so I hope you have understood the concept. I have told you about the formation of boundary layer and I have told you what is boundary layer thickness, displacement thickness, momentum thickness, energy thickness, and the formula of shape factor, von Karman equation, and drag coefficient and drag force. And further in the end I have told you about boundary layer separation and its concept. That is all we have covered yesterday. I will give you 4 to 5 questions and then after that I will start dimensionless analysis, but that too not in depth. I am just going to tell you what is dimensionless analysis, what are the dimensionless number, and what are different models law. That I am going to discuss in this session. Okay. So now let's, without any delay, let's start the session now. Now this is a very brief introduction about me. So every day I tell you about my introduction. You can read it here. I am Vikas Bhadoria. Those who don't know that my name is Vikas Bhadoria, this is a brief introduction about me. I am Vikas Bhadoria. I have 5+ year teaching experience. I did my M.Tech in thermal engineering. I have mentored more than 10,000+ students for different competitive exams. And my area of expertise is mainly fluid mechanics, thermal applied and heat transfer. Okay, so that is a brief introduction about me. Now, like I have promised you all, I will bring you some question of boundary layer, but I don't want this number of students, that this is a very less number of students who are watching us right now. I just want this number to be more, okay? So please share it to your friends so that more and more participants should be there for this very important session, okay? Now this is the first question. Those who have attended the lecture of yesterday, that is of boundary layer, you can solve this question. I have got 5 questions for you all from boundary layer, so you can solve the question, tell me the answer in 1 minute, and then we'll start the topic of dimensionless analysis, okay? Yes, so please solve the question and tell me the answer. In this question, they have given that for a flow velocity distribution is given as u by u, where capital U is the free stream velocity, is equal to half of y by delta, okay? Displacement thickness is given by delta star and the momentum thickness is given by theta. So you have to tell the this ratio, displacement thickness minus momentum thickness divided by boundary layer thickness. What will be the value of this ratio? Okay, so solve the question and tell me the answer. Harsha, Harry, if this is your first class, then I welcome you for this very first time if you are attending the session of fluid mechanics. Jagveer Singh, definitely, I will definitely revise the complete fluid mechanics, okay? Yes, come on guys, hurry up, solve the question. So this is your first question. So maybe today my students are busy somewhere, they are not here in the session, because every day we have around 20-25 students live, but today we have got very less students. So maybe they are busy in their dinner and some other stuff, so that is why they are not there live right now. No problem, I'll be teaching all of you, those who are present in the session. Yes, come on guys, solve the question, tell me the answer in 1 minute. Yes, come on, be quick, hurry up guys. Hi Pavan Kumar, very good evening to you. Yes, Manjunath, definitely if you are preparing for GATE 2021, it's not required that you should get enrolled in some coaching, but yes, it's totally depend on your time availability. If you are not able to give 100% dedication to a coaching, if you are not able to give time to a coaching, what you can do is you can buy a paid course from some video, or you can join this Vision 2021 paid course. You can find the link in the description of this video. In that also we are providing everything for GATE 2021. Okay, so you don't need to go anywhere. Okay, you just need to log in this, take the session from your home, and you can prepare for GATE 2021. Manjunath, Manjunath, not Manjunath. Hi, Saurya Jyoti Das, very good evening to you. Yes, has anyone solved this question? I have given you enough time for this. Has anyone solved the question? Got the solution? Yes, Raj Singh, if you are in the B.Tech second year, then also it is the right time, because if you are from mechanical branch, I hope you are from mechanical. So the technical subjects in the B.Tech start from second year onwards, okay? So if you are in the second year, definitely it's going to help you. And so you can follow our Vision 2021 course, and you will be very much, good in all the subjects, and that means what you can do is you can join this Vision 2021 course in second year, and at the end of the second year you will be very good in all the subjects. In the third year you can revise all the concepts, and in the final year when you will give the GATE exam, you will definitely come out with flying colors. Raj Singh, so definitely that is a very good opportunity if you are in the B.Tech second year and you are so much serious for the GATE exam. That is really very good and commendable, very good. Yes. Yes, Suresh Kumar, have you solved the question? If I am giving a good concept, so please give me the answer for this question. So I think none of the students have given the answer, so better I think I should solve the question. So in this question, this velocity profile is given, this is the velocity profile. You have to find this ratio, Okay, so let us find the displacement thickness. It is equal to 0 to delta of 1 minus u by u, that is free stream velocity, local velocity of free stream velocity dy. Okay, so this ratio is equal to half y by delta, so that will be equal to 0 to delta of 1 minus half of y by delta dy. So if you integrate, you will get this value as y minus half of y square by 2 delta, that is it will be equal to 4 delta 0 to delta. If you solve it, you will get this value as, this will be equal to delta minus delta square by 4 delta. This will get cancelled. You will get 3 delta by 4. That will be equal to 0.75 of boundary layer thickness. So you will get this value as 0.75 of boundary layer thickness. Now let's come to momentum thickness. How you are going to find the momentum thickness? Momentum thickness is equal to 0 to delta times of u over free stream velocity 1 minus u over free stream velocity into dy. So if you put the values of velocity profile in this equation, what you will find that after solving it, I hope some of the students must have solved it. So that will be come out to be delta by 6, that is 0.167 of delta. So if you put the values of displacement thickness, momentum thickness and boundary layer thickness in this equation, you will get this value as 0.583. So those who have solved the question and they have got the answer, the correct answer is 0.583 for this question. Okay? Yes, have you solved the question, everyone? Or have you understood the solution? Please say yes or no if you have understood the solution. The answer will be 0.583. Next question, at a point A, which is 2 meters from the leading edge, boundary layer thickness is 3 mm. Another point B has a boundary layer thickness of 4 mm in the same viscous flow. The distance between the 2 points is. It is a conceptual question, and so this question is from boundary layer thickness concept again. Now you have to figure out whether the flow is a laminar flow or turbulent flow. So is there any hint given for that, whether the flow is laminar or turbulent? Yes. How we can identify whether the flow is laminar or turbulent? They have given that. They have given in this question that the flow is a viscous flow, and I hope you have gone through the lecture of laminar flow through pipe. Laminar flow is also called a viscous flow, highly viscous flow. Okay, so that is why they are saying that it is for the laminar flow. Now you have to find the relation between boundary layer thickness and the distance from the leading edge for the laminar flow. What is there any relation for that? So you have to find that relation and solve the question. Okay, so I am giving you 1.5 minutes for this question. Be quick. Yes, Raj Singh, you are correct, because viscous flow is also called laminar flow. That is very correct. Shivam Pal, you are also right. Yes, hurry up guys. Be quick. So firstly you have to find a relation between boundary layer thickness and the distance from the leading edge. Okay, is there any kind of relation for that? If there is some relation, you have to solve the question then. Yes. Sai Ram is saying that the answer is 3.5 for this question. Okay. So are you 100% sure, Sai Ram, that this answer is correct? Your 3.5 answer is correct for this question. See, this is an 80 type question, so I am not going to tell you the right answer. You have to tell me the answer here. Kumar Anubhav is getting 3.55. Okay. See, these are the gate questions, so you have to think a lot. So whenever you are solving a gate type question, you have to read the question carefully. What is given in the question? Then only you will get the right solution. Understand? It will be not very easy question, definitely, because it contains a concept. Okay. So far no one of you have got the right answer. So I think I should better tell you the solution. Okay, so Kumar, Anubhav and those who have given the answer, that is very good, but that is not the right answer for this question. They are saying that at a point A, first of all, the boundary layer thickness for a laminar flow is equal to 5 into x over under root of Reynolds number, right? Now this relation we can obtain, we can write this relation. If velocity profile is not given, then from Blasius relation we can write that, or Blasius equation we can write that for laminar flow, the boundary layer thickness is equal to 5 into x over under root of Reynolds number. Now Reynolds number is further equal to, it can write it this as 5 into x under root rho into v into x over mu. So this x will go this side, you will get, because you have to find the relation between delta and the distance from the leading edge. So what relation you will get, this as delta is equal to directly proportional to root x for a laminar flow. So for a laminar flow, we can write that boundary layer thickness is directly proportional to square root of this distance from the leading edge. Okay. So when you will find this relation, after finding this relation, you have to just put the value of delta A over delta B will be equal to under root of XA over XB, right? Now if you visualize this question, just visualize this question. Yes, we have got one right answer now. Atul Sharma is correct. The answer will be 1.55. So Atul Sharma, you are correct. So delta A, let us say there is a boundary layer. So they are saying that at point A from the leading edge, let us say at point A from the leading edge, at a point A 2 meter from the leading edge. That means this is 2 meter from the leading edge. This is the leading edge. So this boundary layer thickness is given as 3 mm. Another point B has a boundary layer thickness of 4 mm in the same viscous flow. So let us say there is a point B somewhere here. Okay, and this has got the boundary layer thickness of 4 mm. What you have to find in this question, dear? You don't have to find the value of XB. You don't have to find XB. Like most of the students were finding the value of XB, that is the distance of the from the leading edge for this point B. No, you don't have to find that. You have to find the distance between the 2 points. That is, you have to find distance between B and A. That is, you have to find XB minus XA. Understand? So that is why I was telling you that you have to read the question carefully. Okay. So if you put the value of delta A, that is equal to 2 into 10 power minus 3 over 4 into 10 power, sorry, that is not 2, that is 3 into 10 power minus 3 is equal to under root 2 over XB. So when you will solve this, you will get XB will be equal to 3.55. Okay, you will get XB is equal to 3.55. Now you have to find XB minus XA. You have to find the distance between the 2 points. That will be XB minus XA. Okay, that is you have to find this distance. Okay. So the answer that you will get is, this was a good question. The answer that you will get will be equal to XB minus XA. That is, you will get this as 3.55 minus 2, that is 1.55 meter. So those who have got the right answer, that is 1.55, that is the correct answer. And those who are not able to think like that, you really need to increase your, or you need to widen your vision. Okay, that how you have to visualize the question. Okay, so you just need to you need to think in the right direction. Okay, you have to firstly read the question carefully. First you need to understand the question, read the question, and then understand that what is being asked in the question. Okay, so that was a good question. Those who have got the right answer, that is very good. Next question. Okay, Kumar and Bhav, if you are not able to understand the question, that is not a problem. So you really need to read the question correctly. That you should not do. Whenever you see any question, especially in a gate exam, the question should be read very, you have to read the question very carefully, okay, because in each and every line of the question, you can have a very important concept. That is a good, that is a beautiful thing about the gate type question, that questions are really very good, okay. So there can be a hidden concept in the question, okay, so you really need to go through the question very carefully. Next question, fluid with velocity v flows over a flat plate and at a point delta is the boundary layer thickness, okay. If the velocity is now increased to 9 times of the original velocity, that is 9 times of the v, then the boundary layer thickness in that case will be. So now in this question, you have to find the relation between boundary layer thickness and the velocity. So solve the question, tell me the answer. So they are also saying that you have to assume the laminar flow, okay. So you have to tell me the answer very quickly. Tell me the answer. Shukla, Abhay, you don't need to be that quick, okay. You are again doing that mistake. Don't be so quick. Read the question carefully and tell me the answer, okay. So these are not, if you are in the B.Tech, these are not your university exams like that you can have that tukka thing, okay. You cannot do the guesswork here, okay. You really need to solve the question. If it is a gate type question, you have to solve it. Maybe you don't require the calculator, the question can be that easy, but definitely you have to solve the question. If that is a gate type question, you cannot directly get the answer. Understand? So Abhishek and Shukla, Abhay, you really need to check the question again. You really need to check the solution again. Yes, those who have solved the question, I can see most of the students in the YouTube, they are giving their options. The right answer, I'm not going to tell you the right answer. Let's see the solution. Tarun Rana is saying option B in the app. Okay, Tarun Rana. And most of the students in the YouTube have solved the question. They have got some answer. So let us see how to solve it. Now the boundary layer thickness is directly proportional to, we can say it is equal to, it is a laminar flow. So that will be equal to 5 into x under root of Reynolds number. So we can say delta is equal to 1 by under root of rho into v into x over mu. You have to find a relation between boundary layer thickness and velocity. That will be this relation. Boundary layer thickness is inversely proportional to square root of velocity. Okay, so you have to remember this relation. Understand? So final relation you will get is this relation. Now in this question they have given that that velocity, let us say velocity is v. Now velocity has been increased. Okay, and you have to find the boundary layer thickness for this increased velocity. That means the relation will be delta 1 over delta 2 will be equal to under root of v2 over v1, right? Because the boundary layer thickness is inversely proportional to the velocity. Now in this question they have given v2 is equal to 9 times of v. That is equal to 3. So delta 1 over delta 2 is equal to 3. Now what you have to find in this question? You have to find the boundary layer thickness when the velocity has been increased to 9 times the velocity. That means you have to find the value of delta 2. Delta 2 will be equal to delta 1 by 3. And let us say in this question delta 1 is equal to delta. So that means the answer will be delta by 3. Sorry. So those who have just marked the answer by merely looking at the question, just looking at the question, it's my request that you have to see the question, you have to read the question, you have to read between the lines. You should be, whenever you are solving a gate type question, you really need to look at the question carefully. The right answer will be option B. Okay. Next question. For a laminar flow over a flat plate, if the free stream velocity of the fluid is 10 meter per second, the boundary layer thickness near to the wall is 10 mm. Okay. Determine the wall shear stress. Take dynamic viscosity as 0.0863 poise. Velocity profile is given by. Sorry, that is not 0.0863, that is 0.863. That should be 0.863. So you have to take the viscosity as 0.863, that is not 0.0863. That is a correction that I have already done. So viscosity is, dynamic viscosity is 0.863 poise. Okay? So solve the question quickly and tell me the answer. So one of my dear student has not liked the content that I was giving here. So he has disliked the session. No problem. I can take like and dislike both as equal thing, because that is your love, and that is, if you are not able to understand some concept, that means that is why you have disliked it. No problem. You can dislike the session, that is not a problem. Okay. Now we have got 2 dislike. Thank you so much. I think I am not teaching anything wrong here, so there is no need for these dislikes, but it's totally up to you. You have got the power, you can do anything. It is your, you just have to click on that like or dislike button, it's totally onto you. So like I can see we have 3 dislikes now. So I'm not going to say anything. Please solve the question. I think it's a fun for you, so you can do that. See, whatever we are doing here, it is for you guys, okay? So it's totally up to you what you want to give me. Whether you want to give me like or dislike, totally up to you, okay? Please solve the question. Yes, thank you so much for your appreciation, Gautaman, sorry if that is. Yes, Abhishek. Yes, please solve the question, everyone. It is a very good question. Thank you so much for your appreciation. Well, thank you so much, Shivam Pal. Please solve the question quickly. In this question, you need to understand that the velocity distribution is this, that is given here. Santosh Kumar in the app, he has solved the question, and he has got the option C as the answer. Well, thank you so much for you all, your appreciation for those good words and kind words. And so please tell me the answer for this question. Well, thank you so much, Raj Singh, for that, those good words for me. I'm really so touched by your good words. If you are watching this Gradeup, especially for me, because of me, so that is very good. Yes, everyone, please give me the answer for this question. Akhilesh Bhagat is getting option 150.23. Well, okay, that means option A, okay. And Sai Ram is getting option B. Siddharth Patel is getting option C for this question. Okay, so I am going to tell you the answer for this question. So let's see how to solve this question. We have got few responses. Those who are not able to solve the question, no problem. I am going to tell you the solution for this question now. Now in this question, they are giving that for a laminar flow or a flat plate, if the free stream velocity is 10 meter per second. So free stream velocity is equal to 10 meter per second in this question. That is given here, okay. Let us take the data which is given here. Boundary layer thickness near to the wall is 10 mm. So boundary layer thickness is equal to 10 mm. You have to convert it into meter, okay. So whenever you are solving any question, whether it is from the subject of fluid mechanics or from the subject of strength of material or from any other subject, you have to convert the dimension, you have to convert the unit into the SI unit, okay. So boundary layer thickness is 10 mm, you have to convert it into meter, alright. Next thing is that velocity profile is given here. You have to find the wall shear stress. Now wall shear stress, I have told you yesterday, if you have watched the session carefully, I have told you that this wall shear stress is equal to mu times of du by dy at y is equal to 0, because this wall shear stress is observed at the wall of the plate, okay, or at the boundary of the plate. That is the wall shear stress formula. It is equal to du by mu times of du by dy at y is equal to 0. Now this u velocity distribution is given here, u by u infinity is equal to this, right? So you have to find that du by dy. So what you have to do, you just have to differentiate this velocity distribution. Let us do that. U by u infinity is equal to 3 by 2 y by delta minus half times of y by delta whole cube. So if you solve this, you will get u, it is equal to u infinity times of 3 by 2 y by delta minus half times of y by delta whole cube. Now in this u, what is the constant? In this you can find that this value is constant, that is u infinity is a constant, so that can be kept outside. What you will find it after differentiation, you will get this as du by dy will be equal to 3 by 2 times of u infinity will be outside, 3 by 2 times of delta minus half times of, that will be, that is differentiation, that will be 3y square over delta cube. Okay. Now you have to find the du by dy at y is equal to 0. At y is equal to 0, this term will be equal to 0 because this term contains y terms, right? So that term will be equal to 0. So du by dy at y is equal to 0 will come out to be 3 by 2 times of mu infinity, u infinity over delta. So this value you will get for the velocity differentiation du by dy at y is equal to 0, right? Now you have to find the wall shear stress, that will equal to mu times of 3 by 2 mu infinity over, sorry, u infinity over delta. Now the question is very simple. If I would be at your place, I can easily solve it. Even if I don't know the solution, now you can easily solve the question, right? You know the value of u infinity, you know the value of delta, you know the value of mu. But this mu is given in poise. The dynamic viscosity is given in poise. That is not the SI unit. That is the CGS unit of viscosity. So you have to convert it into the SI unit of the dynamic viscosity. Now SI unit is Pascal second. Now we know that 1 poise is equal to 0.1 Pascal second, right? Or 1 by 10 Pascal second. So 0.863 poise will be equal to what? 0.863 poise will be equal to 0.0863 Pascal second. Okay? So you just have to put this value here and put all the everything, that is u infinity, delta and this dynamic viscosity, you will get the answer that will be equal to 129.45. Okay, so that was again a very good question from the concept of boundary layer. So I have told you yesterday that this boundary layer is a very important concept, especially from the subject of fluid mechanics. This is one of the preferred topic from GATE exam point of view. Okay, so that is a very good question. So let's move on to the last question of the day. Last question from boundary layer. Then we will start the topic of dimensionless analysis. Okay. So come on guys, solve the question quickly. Yes. So Jagveer Singh has solved the question, that is he has got 129.45. Madhu, yes, that is correct. 3 into mu into viscosity into free steam velocity divided by 2 delta. That is correct, Madhu. The value that you have got for this du by this wall shear stress, that is correct. Okay. Yes, come on guys, solve this question. Last question. In this question, they have given that water flows over a flat plate at a free stream velocity of 0.15 meter per second. Take dynamic viscosity as 10 power minus 3 kg per meter per second. There is no pressure gradient and laminar boundary layer is 6 mm thick. So they are saying that it is a laminar flow because laminar boundary layer thickness is given in the question. Assume the velocity profile to be this. For the flow condition stated above, calculate the skin friction coefficient. You have to find skin friction coefficient. I have told you the formula for skin friction coefficient yesterday. So I hope you remember that formula. Now solve the question. Now solve the question. If you will remember the formula, you can solve the question very easily. So for solving the question of boundary layer, you need to remember the formulas. You need to understand the question, because the question can be conceptual. Also, they can be direct formula based. So really need to go through the question very carefully. And for formula, you can make a short notebook for formula. And there in that notebook, you can write all the important formula for the subject of fluid mechanics. You can make a short formula notebook for fluid mechanics subject. Okay. And that formula notebook will be very much helpful for 1 week before the GATE exam. Or 1 week before any exam. If you are preparing for any exam, you should have a short notebook for important formulas and important concepts. Because you cannot every time go through my lectures or go through any lectures or go through any books, especially 1 week before the exam. So you should have one short notebook of your own. Okay. So that is one of the important thing that I used to tell my students every time in the lectures, that you should have a concept notebook, or you should have a short formula notebook with you. Okay, it is a very important weapon for you. It is a very important tool for revising all the everything for any subject. Okay. Yes, guys, please solve the question. You need to read the question carefully. You need to identify the right formula for solving this question and right approach for solving the question, and tell me the answer. So come on, guys, this is the 5th question for today's session from boundary layer. Then we have to start dimensionless analysis also. So Siddharth has got option B for this question. Okay, Siddharth. So I will tell you whether the answer is correct or not. So after some time, you have to wait for some time. Okay. What about those who are watching us in the YouTube channel? Have you solved the question? Yes? Yes, tell me, guys. Rushikesh Paralkar has got option B. Pawan Kumar has got option B. Abhishek, I am waiting for you. We can take your time. I am giving you last 30 seconds. So if you are about to solve the question, you can tell me the answer. Abhishek Kushwaha is getting option B. Kumar Anubhav is getting option B. Santosh Kumar is getting option C. Okay. Ganesh Naik is getting option B. No, Apurva, you should not say that this cannot be possible. Never say anything like that. Okay, just try the question. And if you will try the question, definitely you will get something. Maybe you cannot get the right answer, but at least you should solve the question. Okay. Don't say nahi hoga. Okay. So Abhishek has got the answer. See, Apurva, that is, I am not able to understand Bengali, so I am very sorry. You can write it in English if you want. Okay. Now, in this question, you have to solve the value of skin friction coefficient. The skin friction coefficient CFX is equal to tau naught over half rho into V infinity square. That is the formula for skin friction coefficient. Skin friction coefficient is always calculated with respect to the wall shear stress. Okay. All right. Now the wall shear stress is equal to mu times of du by dy at y is equal to 0. Okay, that is the formula for wall shear stress. All right. Now the value of velocity gradient is given to u by u infinity is equal to y by delta. So you have to again find the velocity. That will be u will be equal to u infinity into y by delta. If you differentiate this with respect to du by dy, that will be du by dy will be equal to u infinity over delta, and at y is equal to 0 also this will be equal to u infinity by delta. So tau naught will be equal to mu times of u infinity over delta. If you just have to put the value of free stream velocity and the boundary layer thickness and viscosity in this equation, and you will find the value of wall shear stress. So what is the value of wall shear stress? Those who have got the right answer is option B, which is the right answer. What is the value of wall shear stress that you are getting? Yes, Sai Ram and Jagveer Singh, Abhishek, see, the question of, the level of the question is, that is the level, and that is the level of the GATE exam also. The questions are not that much tough, they are conceptual questions, okay. Yes, come on guys, what was the value? So from here you can get the value of this wall shear stress from here, okay, and you just have to put the value of wall shear stress in this equation. Value of density will be for water, that is 1000, and the free stream velocity is 0.15. So just put the value of wall shear stress from here in this equation and everything, you will get the answer, that is 2.22 into 10 power minus 3. That is the value of wall shear stress, okay. Kumar Anbhav, that direct formula you cannot use for the finding the wall shear stress skin friction coefficient, because what I told you yesterday, that skin friction, those Blasius equation will be used if velocity profile is not given. If velocity profile is not given, then only you will use the direct formula of the skin friction coefficient or the boundary layer thickness, okay. But if velocity profile is given to you in the question, then you have to solve the question by this formula, okay. Then you cannot use the Blasius equation. Blasius equation will only be used if velocity profile is not given. Understand, Kumar Anbhav? So you have to use the Blasius equation only when velocity profile is not given the question, okay. So that was a good question again, and so I hope you have understood it. Now let us solve the question. Now the topic is dimensionless analysis. Those who are, yes, Arun, the answer is option B, and that is correct. So if you have got the answer, that is very good. Yes, Tarun Rana, yes, the wall shear stress for the last question was 0.025. That is the value of wall shear stress. Now the topic of today's session is dimensionless analysis. If you have studied the fluid mechanics subject in your B.Tech already, that is again a very important topic, and the question that normally you guys get in your B.Tech are from the Buckingham PI Theorem or from Rayleigh Theorem. But if you see the GATE type question, if you see the GATE questions, the question are not from the this dimension analysis. It is from dimensionless analysis. Okay, so what is this dimension? Any physical quantity is represented by some unit. For example, velocity. Velocity is measured by meter per second. It has got the unit of meter per second, right? Acceleration, that is meter per second square. Time, the unit is second. Length, the unit is meter. So every physical quantity is measured by some unit. Now all this unit has got some dimension. What is the dimension? For example, velocity. Velocity, which is having the unit of meter per second, it is also represented by the dimension. What is dimension? Dimension means, for example, length. We have got these three basic dimension: length, mass, and time. Let us say these are the physical quantity. The unit of length is meter, that is m. The unit of mass is kg, and time is second, right? And the dimension of the time is t, mass is m, and length is l. So we can say these three things are called as three basic dimensions. These are three things are called three basic dimension. Okay. So we can write it as MLT or LMT. These are called as basic dimension. So if we have to find the dimension of velocity, that will be meter per second. That means it will be LT minus 1. That is the dimension of the velocity. Similarly, you can find the dimension of acceleration, or you can find the dimension of force, dimension of power, dimension of work. Any dimension, any physical quantity can be represented by a unit as well as some dimension. Now this topic is not about finding the unit and dimension. In this session, I am going to tell you what is dimensionless analysis. I'm only going to tell you what is important for you to remember. Okay, that means what is important for your GATE exam. Okay. So dimensionless analysis is a method of dimensions. It is a unit of, that is the meaning of dimensionless analysis. It is a method of dimensions. It is used in the research work and for conducting model test. Okay, so especially for conducting the model test, for comparing a prototype and a model, we do this dimensionless analysis. Okay, so what is a prototype and model? That I am going to tell you very soon in this session. Okay, now it deals with the dimension of the physical quantity. All the physical quantity are measured by the comparison with length, mass and time. These are the called fundamental dimension. And why this MLT are called fundamental dimension? Because all the physical quantity have got at least these three basic dimension, that is MLT. Every physical quantity will have this basic dimension MLT. Okay. Now what are the secondary dimension? All they possess more than one. A dimension which possesses a physical quantity which possesses more than one fundamental dimension. For example, velocity. For example, acceleration. For example, force. All these are called as secondary dimension. Okay. Example, velocity, density, acceleration. These are called secondary dimension because they contain more than one fundamental dimension. Okay. In any problem of fluid mechanics, heat is involved, then temperature is taken as fixed dimension or not. Well, last thing, see, if the question is from fluid mechanics, you cannot have analysis of temperature. Okay, so see, that is a concept because we are discussing about the boundary layer, because we have discussed flow over a plate. So in the heat transfer subject also we have this convection heat transfer in a pipe and in the plate. Okay, so that is quite confusing, but you have to distinguish whether the question is from fluid mechanics or heat transfer. If the question is from heat transfer, you have to do the thermal analysis, but if the question is from fluid mechanics, then you should not consider the temperature in that case. Okay, because in fluid mechanics we don't consider the temperature thing. Okay, that is not part of fluid mechanics. Now in this table you can find that different physical quantities are given, their units are given and their dimensions are also given. Their symbol is given and their dimension is given. For example, area has got the dimension of L square, volume L cube, velocity Lt minus 1, angular velocity is T minus 1, acceleration is Lt minus 2, angular acceleration is T minus 2. Similarly, you can find the dimension of each and every physical quantity which is given in the table. Okay. Now, if we are talking about dimensionless analysis, let us understand what is dimensional homogeneity. So, whenever you will find this equation, well, Arun Kumar, yes, this topic is important for both GATE and ESE. That is why we are covering the topics which are important for both this exam. Okay. So, dimensionless homogeneity. Homogeneity means equality. What is the equality? Whenever you are writing an equation, for example, kinetic energy is equal to half mv square. Okay, whenever you write any equation, this should be dimensionally homogeneous. That means the left side of the equation should be equal to right side equation in the case of dimension. If you see the dimension of the left hand side and right hand side of any equation, it should be same. That is called as dimensionless analysis. Okay, so that is called dimensionless homogeneity. That means the dimension on the left hand side and right hand side of the equation should be equal. Now, if you have to do dimensional analysis, not dimensionless, but dimensional analysis, we have got two methods, Rayleigh method and Buckingham PI Theorem. Okay, but since I have told you that I am not going to teach you dimensional analysis, I am only going to tell you dimensionless analysis. So I am going to avoid it. Okay, because for the GATE exam, this does not come in the GATE exam. But yes, in the engineering services that can be asked to find the dimensional analysis, but that is not important for GATE exam. Okay, so in this method of dimensional analysis, we have two methods, Rayleigh method and Buckingham PI Theorem. Okay, so if we have to perform dimensional analysis, we have to do two methods. Now, Rayleigh method is used for determining the expression of a variable. How this expression for kinetic energy is, you are getting this as half mv square, or how we can write this time is equal to 2 pi under root L by G, or any kind of relation, any kind of equation is written with the help of these dimensional analysis. Okay, now for the GATE exam, this does not come in the syllabus of GATE exam. You cannot find as such question from dimensional analysis. The question only comes from dimensionless analysis. That is why I am not going to cover it in detail. Okay. So, but I just want to give you the brief idea about it. Rayleigh method is a method for determining the expression of a variable like this. and it depends on maximum on 3 or 4 variable. It is only used for dimensional analysis of 3 or 4 variable. Rayleigh method is only used for 3 or 4 variable. Okay. So let x be a variable which depends on these 3 variables. Okay. Then according to Rayleigh method, x is a function of x1, x2 and x3. X is called as a dependent variable. It is called dependent variable. And x1, x2, x3 are called as independent variable. So about Rayleigh method, there is a constraint that it is only used for maximum 3 or 4 variable. You cannot go more than 3 or 4 variable if you have to perform the dimensional analysis by Rayleigh method. Okay, so to avoid that problem, we have a Buckingham PI Theorem. What is Buckingham PI Theorem? Buckingham PI Theorem removes the constraint of Rayleigh method. That means if you want to perform the dimensional analysis for more than 3 to 4 variable, you can use Buckingham PI Theorem. So what is the Buckingham PI Theorem? It says that if suppose that in an equation there are n variables, n number of total variables, and it has got m number of fundamental dimension, then according to Buckingham PI Theorem, you can represent it in the form of an equation containing n minus m dimensionless groups. So if any equation we have n number of variables means any number of variables, and it should contain at least m number of fundamental dimension. Fundamental dimension means MLT. Okay, if any equation contains n number of variables and it also contains m number of fundamental dimension, then this can be represented by n minus m number of dimensionless pi terms. Dimensionless pi terms. Okay. So that is all about the Buckingham PI Theorem. I think you should not know more than that. Okay, especially for the GATE exam, that is not important. So that is why I'm just moving away further, because like I have told you that I'm only going to teach you in this session the important thing for GATE exam, because that we have promised yesterday that if I'm going to take 5 questions of boundary layer, I'm not going to teach you much for dimensionless analysis. But I'm going to tell you everything which is important for GATE exam. Okay. Now how the question comes in the GATE exam? The question comes from model prototype relationship. Okay. You have to solve the question of this question from Reynolds model or Froude model. Now to understand the different types of model, you have to understand how these models come from. So there are different models which are depends on dimensionless number. Now these dimensionless number, for understanding the dimensionless number in the fluid flow, you have to understand the various kind of forces. So there are different kind of forces in the fluid mechanics. It can be inertia force. Inertia force is equal to the product of mass and acceleration and acts in the opposite direction to the acceleration. That is called the force of inertia, and that is equal to mass into acceleration. You will get this value as rho L square V square. That is the force of inertia. Next force that you have to understand is surface tension force. Surface tension force is equal to the product of, we know that surface tension is equal to force per unit length. So surface tension force will be equal to product of surface tension into length. That is the surface tension force. This is equal to sigma into L, where sigma is the surface tension. Next force is the gravity force. Now gravity, as you know, it is equal to product of mass into acceleration due to gravity. So that is equal to m into g, and in terms of formula, it is equal to rho into L cube into g. Okay, because this unit of mass is rho into L cube. Okay, and this acceleration due to gravity is g, so that is rho into L cube into g, for that is the value of gravity force. Then we have pressure force. Pressure force is equal to product of pressure into area. That means it is equal to rho P into L square. Okay, viscous force is equal to product of shear stress due to viscosity, and it is equal to mu into A into V by G, that is mu into L square into V by L. By solving it, you will get this as mu L into V. So we are writing all these forces in terms of their dimensions. Okay, in terms of dimension, it is equal to mu into L into V. That is the viscous force. And finally, we have elastic force. It depends on the elastic stress, and the area, it is equal to K into L square, where K is the bulk modulus of elasticity. It is bulk modulus of elasticity, and L is the area, L square is the area. Okay, so that is all the different kind of forces we use for the analysis. Now, after understanding these different kind of forces, these number of forces can be represented with the help of some dimensionless numbers. Now, what are those dimensionless numbers that we use for this dimensionless analysis? These numbers are Reynolds number. Reynolds number is basically used for pipe flow and a fully submerged flow. For the condition of pipe flow and fully submerged flow, we use this Reynolds number. Nahiyan, Tasmeen, this topic is on dimensionless analysis. And Prakshit Sharma, very good evening. You are late for the class, but no problem. You have joined at the right time. We are now understanding the concept of dimensionless numbers. Okay. So Reynolds number is equal to ratio of inertia force over viscous force, and the formula that you get is, you know that this formula, it is equal to rho into V into L by mu, where L is the characteristic dimension. It is not the length, it is the characteristic dimension. Okay. Inertia, next is Froude number. Froude number is defined as the ratio of square root of inertia force over gravity force. That is called as Froude number, and this number will come out to be V over under root L into G. We are just putting the forces that we have seen in the previous slide in this ratio of inertia force over gravity force. Square root of that is equal to V by under root Lg. That is called as Froude number. Next is Euler number. So Froude number is used for the application of in the condition or cases where spillway, notches and wear. In these cases we will use the Froude number. Okay. Next is Euler number. Euler number is equal to ratio of square root of inertia force over pressure force. Square root of inertia force over pressure force, that is called as Euler number, and the formula for Euler number is equal to V. V is the velocity under root P by rho. That is the formula for Euler number. Okay. And it is used for the flow of study of cavitation. We use the Euler number. Next is Weber number. Weber number is equal to square root of inertia force over surface tension force, and that comes out to be equal to V over under root sigma over rho L. That is the formula for Euler number. Weber number. And then finally we have Mach number. Mach number is, I hope you already know about this Mach number. We also use this Mach number for this flow of compressible fluids, for the flow of nozzle, steady nozzle. Okay. Mach number is equal to ratio of inertia force over elastic force, square root of inertia force over elastic force, and that comes out to be equal to M over V under root K by rho, or it is equal to V by C, where C is called speed of the sound, and that is equal to under root K by rho. K is the bulk modulus of elasticity and rho is the density. That is the formula for this Mach number. Okay, so these are the 5 dimensionless numbers that you have to study. You need to understand, that you have to remember. But for your GATE exam, if you see the questions, the question that comes from dimensionless analysis, the question comes from Reynolds number and Froude number. You have to remember only 2 numbers for your question of fluid mechanics, that is Reynolds number and Froude number. Okay, because why we have to remember these 2 numbers? Because now comes the important topic, that is called model law. What is the purpose of this model law? See, can you imagine that how a submarine is made? Okay, how we design a submarine? We don't directly make a submarine. We don't directly make a wind tunnel or a very big. You cannot directly make a big thing or big aeroplane just by making the actual thing. Okay. Firstly, you have to make a model of a prototype. What is a model of what is a prototype? Prototype is defined. Prototype is the actual product. The actual product is called as prototype, and the small replica of that product, a small replica. That means the replica means the exactly similar to the prototype. The small replica of the actual prototype is called as model. Okay, so what is this model analysis? If you are in the B.Tech, in the final year of your B.Tech, you will definitely make a model. Okay, so models are definitely in small in size. Okay, so you need to understand the concept of model and prototype. Model is it is the exact replica. It is the exact replica of the actual prototype. Actual prototype. Now in the layman terms, if you're not able to understand what is model prototype, I just want to make you understand in simple terms. Model is a small, it is always on a small scale, and prototype is on the big scale. It is always on a big scale. For example, if you visit any lab, when you visit any lab, if you visit a lab of thermodynamics, this power plant, this fluid machinery lab, what do you find in the fluid machine lab? You will find the model of a turbine, you will find the model of actual working model of a turbine, right? Or working model of a pump, right? Those are called as model. Okay, these are very small in size. Those are not the actual turbines. Okay, the turbines that you see in your fluid mechanics lab or hydraulic machinery lab, those are not the actual turbines. The actual turbines are very, very big in size. Okay, so you need to understand the models are always a smaller size. The smaller size is called as model. The bigger size, the thing which is in bigger size, which is the actual thing that you have to make after doing all the tests on the model, you have to make the prototype. Okay. So if you have to make a big submarine, firstly you have to make a small submarine model. You have to conduct all the tests on that small model, and then after understanding, okay, this is going to work, then you make the bigger prototype, which is the original product. Okay, so that is the whole concept of model analysis. Model analysis is basically done to compare this model and prototype so that you can go with your design and make your actual prototype. Okay, so that is the whole concept, and now let us continue further. So for doing this model analysis, we have two kind of studies. One is called Reynolds model, another is called as Froude model. Arvind Selva, well, yes, there is a trick. If you have to remember anything, there is a trick for that, and that trick is that just write that thing so many times that it comes into your memory. Okay, if you are in a practice of writing and reading, you can remember anything. But if you are in a practice of only reading something, you cannot remember or recall something. So just be in a habit of writing and reading. You will definitely learn anything. Okay. And still, if the formula is very big, it looks very tough to you, you can write that formula, stick it on the wall in front of you, and every time you can watch, we can just go through it and you will remember it. Okay. So Reynolds model law is, according to this model law, all the models are, if you have to compare two different models and prototype, you can do in terms of Reynolds number. Okay. So models based on Reynolds number include pipe flow and resistance experienced by submarines, airplanes, fully immersed body. So in the condition, the condition in which you have to apply the Reynolds model law is the pipe flow, the flow in the submarine, the flow for the fully immersed body, for these or submerged body, we will using the Reynolds model law. These are the condition in which we use the Reynolds model law. Okay. So for Reynolds model law, let us compare two different a model and a prototype. Okay. So what you have to do is, you just have to compare Reynolds number of the model with Reynolds number of the prototype. That is the only thing you have to do, and that's it. So let us say that if you are comparing Reynolds number of a model and prototype, what you can do is, Reynolds number of the model will be equal to rho into V into L over mu, right? That will be equal to Reynolds number of the prototype, rho into V into L over mu of prototype. Now, this confusion that also comes in some of the students' mind. Sometimes they can write L or length of the prototype or model. They can also write this Reynolds number as rho into V into D over mu. So it totally depends whether it is a pipe flow. If it is a pipe flow, in that case, you have to use diameter. They will be giving the value of diameter. If it is a flow over a plate or it is a flow in a fully submerged body. If it is a fully submerged plate, in that case you have to use L. So it depends on what is given in the question. You can either use L or D. It depends totally on the question. Understand? That is all I have to tell you here. For comparing the Reynolds model, by using the Reynolds model, you have to just equate the Reynolds number of model and prototype. Okay, now in this Reynolds number of model prototype, what you have to say is that, let us say that Reynolds number of model prototype is compared. So what you will get is, you will get the scale ratio for density, scale ratio for velocity, scale ratio for length, and scale ratio for viscosity. So according to Reynolds model, if you have to solve the question for Reynolds model law, you just have to compare the Reynolds model of model and prototype. Okay, so if you compare it, let us say the velocity of the prototype is equal to Vp, velocity of model is Vm, length of the prototype is Lp, length of the model is Lm, and the viscosity of the prototype is mu p and velocity of the model is mu m. Okay, and density of the model is prototype is rho p and density is model is rho m. Okay, so this thing will be given you in the question. The corresponding values of velocity, density, viscosity, and length will be given to you in the question. You just have to find the thing which is not given. Okay, so you just have to compare this Reynolds model law and you will solve the question very easily. Okay. In fluid flow problem where viscous force are prominent, the models are designed on the basis of Reynolds model law. Yes, that is correct. Singh Saurav, see, as per the format of these classes, for this course of StartUp ME, for these free classes, the classes should be in the language of English. So I cannot speak English that much. But yes, if you have any problem in understanding anything, you can let me know. Okay, if you want me to explain in Hindi, if you have stuck at some point, I can definitely explain it. But I cannot speak in Hindi that much. I cannot take the lecture forward with in the Hindi language. Okay, so मैं आपको ये समझाना चाहता हूँ सिंह सौरभ, अगर आपको समझ में नहीं आया है कि रेनॉल्ड्स मॉडल लॉ तब यूज़ करते हैं जब आपका पाइप फ्लो होता है या फिर कोई बॉडी फुल्ली सबमर्ज होती है पानी में. In that condition, we will using the Reynolds model law, and for using that, you just have to equate the Reynolds model of Reynolds number of model and prototype. Okay, so you can solve the question from there. The values will be given to you in the question, and you have to just solve it. Okay. Well, Madhu, that is also the formula of characteristic dimension. But if you see the question of dimensionless analysis, for solving the question of dimensionless analysis, normally they don't give you the value of 4a by p. That we will not be using for solving the question of this dimensionless analysis. For that, they will give you the value of length and velocity ratio. Sorry, length ratio. They will give you the value of scale ratio. In the question, if you see the previous year question, they will give the value of scale ratio for solving the question. Either it is a Reynolds model law or fluid model law. Okay, so what is the scale ratio? It is very, very important to understand the scale ratio. Otherwise, you will do mistake in solving the question of Reynolds model law or fluid model law. Okay, so this scale ratio is basically defined as the ratio of length ratio, which is equal to length of the prototype over length of the model. Or it can be equal to, LR will be equal to diameter of the prototype over diameter of the model. Okay, that is called as scale ratio. So scale ratio can be equal to ratio of the either length of the prototype or length of the model, or it can be equal to diameter of the prototype or diameter of the model. Now, how the question comes in the exam? In the question, they can give you the value of scale ratio as 1 by 50. Now tell me, if scale ratio is given to you as 1 by 50, what is this scale ratio LP by LM or LM by LP given to you? Because I have told you in the beginning that model is always small in size and prototype is always bigger in size. So length ratio or scale ratio for length is equal to length of the prototype or length of the model, or diameter of the prototype or diameter of the model. So if it is given to you 1 by 50, if it is given to you 1 by 50, characteristic dimension we need to use in place of duct, but you are saying length of the duct. See Madhu, see that is another concept of characteristic dimension. Let's not go into that. Okay. So we are talking about dimensionless analysis. In that, scale ratio will be given to you. They will not give you giving the value of this area of the parameter. That is the thing of when we solve the question of flow over a basically in the fluid mechanics topic. You don't come across any question like that. This question of duct, this characteristic dimension are solved for force convection heat transfer. Okay, so when you will be studying heat transfer subject, in that you will definitely be using this concept of characteristic dimension in terms of flow in the rectangular duct. Okay, but as such in the fluid mechanics you don't use this, especially you study in the fluid mechanics flow in the pipe or flow over a plate. Okay, so you don't use the concept of this characteristic dimension in terms of area 4 into area or perimeter, that we don't use in the fluid mechanics as such. Okay, but yes, that concept is used in the force convection heat transfer. Okay, so let's not divert our attention over there. Okay, so this length ratio, if it is given, this is given, that means this ratio is Lm over Lp is given to you in this question. What is given in this question? They are giving you Lm over Lp is equal to 1 by 50. Because you need to understand that Lp is always greater than Lm. So if they are giving the scale ratio as 1 by 50, that means they are giving you the value of Lm over Lp. Understand? So that means if you have to find the scale ratio for solving the question, you have to write length ratio is equal to 50. That is Lp over Lm is equal to 50. Understand? You have to always remember that if scale ratio is like this, if it is given to you 1 by 20, if it is given to you 1 by 100, that means Lm by Lp is given to you or Dm by dp is given to you. But scale ratio for length is equal to Lp by Lm. So you have to convert into that for solving the question. Okay, so that is a very important thing that you need to understand. Okay, and this thing is more important when we will be using the Froude model law. So next is Froude model law. Froude model law is basically used for the condition involving flow over a free surface. That means flow over a flat plate. For flow over flat plate, you have to use the Froude model law. So when you will be having any question of free flow over a free surface or flow over a flat plate, flow over the spillway, notches, weir, sluice gate, channel flow, flow through jet, in all these conditions, in all these applications, we have to use the Froude model law. Understand? Then according to this, Froude model law, not Reynolds model law, according to Froude's model law, Froude number of model should be equal to Froude number of prototype. In that case, this will be Vm over under root G m by Lm should be equal to this. From here, you will find that you will get a relation in the Froude model law. Okay, what relation you have got? Relation of a velocity ratio with respect to length ratio. And the relation is that velocity ratio, which is equal to Vp by Vm, is equal to under root Lp by Lm, or it is equal to under root Lr. So this is the first relation that you get from the Froude model law. Okay. Now how the question will be asked in the exam? The question will be asked in the exam that a scale ratio will be given to you, or they will give you the velocity of the model, and they can ask you the velocity of the prototype. So if they ask you question like that, how you are going to solve the question in that case? In that case, if length ratio is given to you or scale ratio is given to you, and they will be asking the finding the velocity of the model or velocity of prototype, so you just have to, let us say scale ratio is 1 by 50. Understand? And the velocity of the model is given to you 5 meter per second. Right? If they will give you a question, and so you and they have they will ask you the application of this Froude model law. Okay. So how you can, let us say they will give you that it is a case of a flow through spillway or flow through notches or flow through wear or flow through free surface. And then you have to apply the fluid model law, you have to find the velocity of the prototype. So velocity of the prototype will be equal to over 5 should be equal to under root. Now LR should, if the scale ratio is 1 by 50, that means LR is equal to 50, not 1 by 50. Okay, because a scale ratio for length is equal to length of the prototype or length of the model. Okay, so from here you can find the value of velocity of the prototype and you will get the answer very easily. Okay, so this is how you have to use the Froude model law. Understand? Next is scale ratio for velocity or scale ratio for discharge. Scale ratio of velocity is already told to you. So from Froude model law you have to find, they can ask you question from scale ratio for discharge, scale ratio for force, scale ratio for power. So I am telling you some scale ratio directly. Scale ratio for discharge will be equal to, which is equal to discharge of the prototype or discharge of the model is equal to LR, which is the length ratio power 2.5. That is the scale ratio for discharge. Similarly, scale ratio for the force, that is the force of the prototype or force of the model, is equal to LR power cube. And the scale ratio for power is equal to power in the prototype or power in the model is equal to LR power 3.5. So we are, the result of the Froude model law is that these are the result of Froude model law. They are only used for Froude model law. We cannot use this in the application. If the application involves Froude model law, then only you can use this relation. We cannot use this relation for Reynolds model law. Okay. So for the Froude model law, velocity ratio in terms of length ratio is equal to under root LR. Discharge ratio in terms of length ratio is equal to LR power 2.5. Force ratio is equal to LR power 3 and power ratio is equal to LR power 3.5. That is how this you can represent this different ratio of force, power, velocity and discharge in terms of length ratio. So you can see from this relation only that how the question will be asked in the exam. The question in the exam will be based on that length ratio will definitely be given to you. Scale ratio will definitely be given to you. Scale ratio will be given, and 90% in the cases they will give you the scale ratio in the opposite order. They will not be giving you the scale ratio. See, Mukul Patil, definitely I cannot change the content, right? If I am providing you some content from the this dimensionless analysis or from any topic of fluid mechanics, I cannot teach you something different in the paid course. But it is not that I am going to teach you this in the same way. In the paid course, I will be covering each and everything in a more detailed way. I will be solving more questions and will be solving the question of both GATE and ESE simultaneously. So that is why, how it will be different. The content is anyhow going to remain same. I cannot change the content. Okay. So in the exam, scale ratio will be given to you. You just have to understand whether it is a Froude model, and then you have to remember this relation. And they can ask you to find the force or power or discharge or velocity for the prototype or for the model if scale ratio will be given to you. So that is how the question will be put in the GATE exam. Okay, so that is all in this topic of dimensionless analysis, and so that is all I have to cover. Now before I end the session, it is very important to tell you about this Vision 2021 course. Like Mukul Patil was asking about this thing, sir. The same content I am going to tell you in this, teach you in this ESE GATE 2021 course. See, content cannot be changed anyhow. Okay, if I am teaching you a concept of dimensionless analysis or for the concept of boundary layer, what I can do in the paid course is I can give you in cover everything in a more detailed and more. I will explain it in more detailed way. Okay, that is all I can do. We can practice more and more questions live. We can understand the concept by solving the question live in the class. So that is all we are going to do. Okay. Now, if we are talking about this Vision 2021 course, which is a paid course which is being provided by Gradeup for GATE and ESE 2021. In this paid course, we are going to cover 550 plus hours of live classes for GATE and Engineering Services 2021. So, in that we are going to cover the complete technical syllabus of GATE and ESE for mechanical. Apart from that, we will also be covering ESE Prelims Paper 1, all the important topics that will be also provided by 150 plus hours of live classes. Okay. Along with that, you will get daily quizzes that will be also part of this course. After the class, you will get a daily quiz, you will get study notes, and you will get conventional assignment for ESE Paper 2 mains exam. Okay, so that is all you will be getting. Along with that, further, you will get the mock test in this course. You will get all the mock tests, subject tests, part tests, full length mock tests for both GATE and ESE. And if you talk about this, what is important in this course, the classes will take place in the evening. All the classes will take place, will be in the evening. So that is a very important thing that you should know. So those who are in the B.Tech final year, B.Tech second year, B.Tech third year, those who wants to prepare with this Vision 2021 course, which is a 1 year, 9 month or 10th month long course, in which we will be covering the complete syllabus in the more detailed way. Okay, will make you prepare you for the GATE and ESE 2021 exam. Okay. Now, apart from this course, what I have to tell you, the link for the course is given in the description of this video. You can find that the link for that paid course is given in the description of this video. And you can also find in the bottom bar, we have provided the contact detail. If you want to have any confusion regarding this course, you can contact on that number 96500 that is given in the bottom bar also. And another thing is that this green card. Now, this green card is a very important thing. In this green card, we are going to, if you want to practice the questions by Gradeup, the question of mock test by Gradeup, you can buy this yearly card and monthly card. In the yearly card, we provide you this card at 499 rupees price. It is, if you want to practice some good questions for one complete year, and you can just purchase this yearly card. You can practice all the mock tests for any kind of exam which has been provided by Gradeup. Okay, so you can practice the test series for any kind of exam if you purchase the yearly card. If you purchase the monthly card, you can practice all the mock tests in that given month. Okay, for which you purchase the monthly green card. So that is the cost of the green card, and that is all the information about the green card. Now, in this session, we have covered the concept of dimensionless analysis. And so tomorrow we are not going to have any classes for this StartUp ME. But we will be meeting you on Monday. So I will meet you on Monday at 9 p.m. With another topic of fluid mechanics. Okay. So we will be waiting till that time. So in that time, what you can do is you can practice the concept of, you can solve the question of laminar flow through pipe, laminar flow through plate, boundary layer and dimensionless analysis. So you can solve the question, and in the session on Monday, you can ask me any doubt. If you have any doubt on any topic, you can ask me any doubt on that day, that is on Monday. So I will be meeting you on Monday at 9 p.m. Till then, what you can do is, you can inform your friend, guys. You can tell your friend that these sessions are going on the YouTube channel of GATE Gradeup, and these sessions are very free. You can also tell your friends, your colleagues about this Vision 2021 course. Okay, so we'll see you on Monday. Till then, what you can do is you can join the Gradeup. You can download the Gradeup app so that you can prep smart, score better, and you can prepare for do your preparation with the Gradeup in the most effective way. Okay, so I will see you on Monday. Till then, prep smart, score better, go Gradeup. Thank you.